In the last video, we talked about how to solve derivatives that involve products of two functions. And then the final thing we got to consider is, well, what if we have a quotient? What if we're dividing, then what? Because we already know that if we have a sum of two functions, we can just differentiate them individually. Same with a difference. When we're subtracting, we can just differentiate them individually. When it comes to multiplying and dividing, that does not work. When it comes to multiplying, we have to do first d second plus second d first. When it comes to dividing, it's even a little bit worse. And again, y comes down to algebra of the difference quotient. And this is the shortest way. You might think doesn't look very short, but this is the shortest way of solving the derivative of when we're dividing two functions. So let's go ahead and look at it for a minute. It says if we take the derivative d dx of f of x divided by g of x, a quotient of two functions, that's equal to the g of x, which is the denominator, the bottom, multiplied by the derivative of the top, minus the top times the derivative of the bottom. And you might notice this is, so far, it's very similar to the product rule, as we're just mixing second d first plus minus first d second. And then all of that is divided by g squared. So again, there's a mnemonic that my teacher taught me in high school that I still remember, which I like to pass it on and teach you guys as well. But the mnemonic that I use to memorize the chain rule is always low d high, in green for some reason. Not that it really matters. Low d high minus high d low, square the bottom, and away we go. So what that is referencing is that in the quotient rule, in order to solve the derivative of a fraction of two functions, we have to take low. So again, it's like that we're calling this the high function, and this is the low function. We do high d low minus low d high. Sorry, I said that backwards already. I don't know why. I'm not really thinking about it. Yeah, sorry. Low d high minus high d low. And then we also need to square the bottom. So basically the denominator will not actually stay consistent, but we'll have the low function squared. So another way, my students taught me a different way of doing this when I was at the community colleges, just that they had learned it, is low d high minus high d low over low low. And I like to tell a story of how my mom learned it when she was in high school many years ago, which is that she was taught the rule ho d high minus high d ho over ho ho. And where high and ho were the two functions, high ho. I'm sure that was reference to whatever that is, hi ho song. Anyways, not as relevant these days probably. Sorry, mom. But yeah, this is how I learned it: low d high, high d low, square the bottom, away we go, or over low low, whatever. There's a bunch of different ways you can memorize it. And just like with the product rule, very similarly to the last video, there's a kind of a shorter way of writing it. F over g quantity prime is g times f prime minus f times g prime over g squared. Or if we're writing it using another form, if capital F represents a quotient of two functions, then f capital F prime, the derivative of this will be consecutively the second times the derivative of the first minus the first derivative of the second divided by the second squared. And again, you'll notice that my notes are kind of similar. They mimic the other page quite a bit. But we need to use the quotient rule anytime we're dividing two expressions involving x, or whatever variable we're differentiating with respect to. So like looking at some examples, notice how, what if we have the derivative of x, square root of x to the fifth over a polynomial, or two polynomials, or whatever, functions involving e, sine, cosine. Anytime there's a division at all, pretty much need to use the quotient rule. There's no way around it. And unlike the last example, a lot of these polynomials can't be divided because they have no simplification. There is no There will be a remainder a lot of times in division that will not always be able to avoid using this rule. Technically, there are some ways of doing algebra to get around it, but in this case, the quotient rule is usually easier than doing it another way. So like in the last video, let's do a couple examples. So notice that in our first example, we have 10x to the ninth over 5x to the fourth. Again, this we could simplify first, but let's practice using the quotient rule. And again, we'll go ahead and highlight high and low. So let's use high will always be in yellow and low will be in green in all of these. So what I'm going to have to do is low times a d high, and then it's going to be minus. This is another thing that's easy to mess up because the product rule is plus, the quotient rule has a minus, and otherwise they're very similar. So low d high minus high d low, and then all of that will always be divided by low squared, or square the bottom, and away we go. Oops. I need to use my highlighter. Sorry. This would be over low squared. And I'll go ahead and put that in parentheses, low squared. And now let's plug everything in. So we've got low, that's again as is, d high. Sorry, that 4 looks too much like a 9. Let me make my screen a little bigger. Minus, low d high. So d high is the derivative of the top. So I would drop the 9, again, using my power rule to take the derivative of the top. So bottom times the derivative of the top minus the top times the derivative of the bottom. So d low, that would be 20x cubed. And again, those two things will be multiplied. Usually we'll use parentheses around them, but since I'm a little tight on space, I'm just going to use the dot for product. And then this is all square. We need to square the bottom, away we go. So we just take the bottom as is, and we would need to square that. And again, they're just like with the product rule, we will want to simplify our derivative to get the simplest form of our answer. Technically, that is the answer. That's our derivative, but usually when we're doing math, right, we don't leave a big, nasty, unsimplified answer. But yeah, so on the top, if we multiply these through, 5 times 90 is 450, x4 times x8 is x12. And then minus, let's make this a little bit larger just to zoom in a bit. 10x to the ninth times 20x cubed again, 10 times 20 is 200. x9 times x cubed is x to the 12th as well. And then in the denominator, if we're squaring something, remember that this needs to be fully multiplied, but 5x4 times another 5x4, that would give us 25x to the 8th. And now in the numerator, notice we have like terms, so we could subtract across the top. 450 minus 200 will be 250. And then once we combine those terms, notice that we have a single fraction involving polynomials. These we can actually just, or involving power functions, these we can just straight divide, because 250 over 25 is 10. x12 divided by x to the 8th, if you remember, we can subtract down to get x to the 4th. And what we come up with is our derivative after all is said and done. And as I was saying at the beginning of this example, this is not the smart way of solving it. Yeah, actually, simplifying it would be a lot easier. But my whole point is sometimes you can't simplify it and you have no choice but to use the quotient rule, because again, the quotient rule always will give you the correct derivative when you're involved when you're solving with fractions. Sometimes there is no other way. But my point originally was, let's say we simplify first, because like in the last video, we can always simplify inside of our derivative if we can. In this case, we can divide through here. So before I take my derivative, I can divide through if I want to. 10 divided by 5 is 2. X to the ninth divided by x to the fourth is x to the fifth. And now, well, that's way simpler. I could just use the power rule to differentiate. That's going to be 10x to the fourth. There's my, sorry, you guys can't quite see that just because it's cut off. My bad. But yeah, what I was saying is we could just divide through first, get 2x to the fifth, and then take the derivative by power rule, and we get the same answer that we got doing it with the quotient rule. But again, the deal with the quotient rule is some examples, like let's look at these next two examples. Sometimes you cannot do these division problems, or you might be able to. Again, I'll leave that as something for you to try on your own. But regardless, it will give you the correct answer in those cases when you can't simplify. So let's move on to the next example, because this one, you can't do it any other way. So let's start off with, again, low D high minus high D low. I'm going to forego the highlighting for now. But yeah, so it's always low D high. So in this case, D high, derivative of 4x plus 12, that's linear. The derivative of a linear function is just its slope, 4. And then minus, so low D high minus high D low. Oops, I forgot my 1, so that's 4x plus 12. And D low, again, is also linear. The derivative of 5x minus 17 is just 5. Or, other way you could memorize that is derivative of x is 1, derivative of a constant is 0. So I get 5 times 1 minus 0, or 5. And my low D high minus high D low. And also, we need to take the bottom and square it, square the bottom, and away we go. And one word of warning before you move on is I've seen a lot of students say, well, there's a 5x minus 17 here and here, and they will try to cancel it. But remember, the cancellation rule with fractions only works if the cancellation is in all of the terms. Notice how this has a 5x minus 17, but this does not. So trying to cancel this with this does not work. Because this does not have anything to cancel. So essentially that's just an incorrect use of algebra. You can only cancel in expressions that are factored, not when there's adding and subtracting across the board. Does not work. And if that did work, wouldn't you like if we're looking at it, the quotient rule as written algebraically, wouldn't you think we would just cancel this in the rule and simplify it if that worked? Because we would write the rule more simply if it did work, but it doesn't. So just as a warning, please don't cancel those, because it will never cancel right in the rule itself. Because we build the rules for you guys as simple as possible, even though it might not seem that way. But yeah, so now what do we do next? Well, we would just like always, well, this is my answer. I want to simplify my answer. So on the top, what I would suggest is just simplifying the numerator first. And usually I would just leave the denominator alone because the denominator is already factored in the form of a square. And so that I usually just won't even mess with at all. So writing all this out, I'll just leave this alone. You could technically multiply it out into a quadratic, but why bother? In the top, though, the 4 will distribute, so this would give me 20x minus 4 times 17. This is not easily in my memory bank, but that would be 3468. And then looking at the next two terms, also remember this negative will distribute to both terms as well as the 5, so that will be negative 20x as well as negative 60. Easy to forget about this negative, but yeah, this would be a positive 60 when we distribute 5 to 12, but negative also needs to be distributed. And so if we now combine like terms across the top, notice the 20s actually cancel, which is sometimes going to happen with such what are called rational functions when we're dividing polynomials. Not always, but 20 minus 20 is 0. And then 68 minus 60 is negative 128. And the denominator, I would just leave it alone in terms of my final answer. And that's about as simple as I can write that derivative, which again is the derivative of our original function. And if you're trying to think about, well, how can I check my answer, or how can I be sure about that? Well, there are a lot of ways to check derivatives using online calculators, such as Wolfram Alpha. I don't know if you've ever heard of Wolfram Alpha, but this is something which, if you're going to use it, you can use computers to check your work, but with your homework, I do not want you guys using these to just solve your homework, because that defeats the entire purpose of doing the homework, is learning how to do it, practicing it by hand. We don't make homework just to waste your time. It's just to get practice to make sure you understand it before you come down to the test, of course. But there are online calculators that can actually do calculus. And I wanted to check it in this case just to make sure our answer is looking good. Because my point here is algebra can be messy. We make mistakes. And when you're working on your online homework, you might run into problems where it's like, sorry, my thing cuts out. I think it's about every 15 minutes or so it decides that it's done. Um, what was I saying? But if you are stuck on your homework and you're not sure what you did, you can always try seeing what a computer gets. That might help you figure out where you went wrong. But some programs like Wolfram Alpha understand all like advanced mathematics, including a lot of calculus operations. So if I type in DDX, it knows that that means the differential operator, and it will solve it. And now if I'm trying to solve derivative of 4x plus 12 divided by, excuse me, I'm going to drink some water, divided by 5x minus 17, I can just type all that in. And notice I'm using parentheses because with the large fraction bar, that's always implied. So if I type that in, just go ahead and hit enter. It will calculate my derivative. And notice the answer, negative 128 over 5x minus 17 squared. Perfect. Got it. Um, and this is how I recommend using such programs as if you want to check your derivatives. Which again, when it comes down to homework, use it to check yourself, not to just solve your homework for you. And when it comes to exams, on exams you need to show all your work anyway. So that will not do you any good on an exam because, well, first of all, that would be cheating. But second of all, it will tell you the right answer, but it will not have the steps. And most of your the points you're going to earn on your exam are not about getting the correct answers. It's about showing your work. So I'll be expecting you guys to show work such as the product rule and the quotient rule as you're solving these questions. And if you're not, I know you probably are cheating. So that's why you always must show your work. Anyways, there are a few more examples to try on your own. And let's go ahead and wrap up this because we are getting a little bit long on this video. There's some more applications in business. We'll talk more about this during a live class session, but you can work through this example on your own if you want. But we'll look at this one in class next Wednesday.